This is a video for MEI Core Pure Mathematics, Calculus 5, Volumes of Revolution and Mean of a Function, 5.2, Rotation about the x-axis. The diagram shows a solid that has been created by rotating the region between A and B under this curve about this axis through 360 degrees. Let's consider this disk as a small part of this whole volume. This disk has a width of delta x and has a radius which is equal to y. If I think of this disk as being an element of the whole thing, then it has a volume, delta v, and that's equal to pi r squared, so that's going to be y squared, delta x times its width. We saw this expression in a previous video, and that this solid is formed by taking lots of these disks between A and B and adding them all together. The volume of this solid then is approximately the sum of all the disks that I've got between A and B, so it's all of their volumes, and that is the sum between A and B of pi y squared delta x. And just as with areas under a curve, we look at what happens to this expression as we allow delta x to get smaller and smaller. So the volume of the whole thing is the limit, as delta x tends to naught, of this sum from A to B of all these disks. And so what happens in the limit is that the volume becomes, well, this infinite sum is the integral between A and B, and I've still got pi y squared, and the delta x becomes the dx. So the volume for this solid is the integral between A and B, pi y squared dx. There's that working written out neatly for you. There's my disk of width delta x and height y for its radius. There's the sum of all the disks, and then thinking about the infinite sum, it becomes an integral. Let's have a look at this example then. I've got the curve y equals x cubed, and I'm looking at the volume as I rotate about the x-axis between 2 and 3. Well, my volume is equal to the integral between 2 and 3 of pi y squared dx. Now my y in this case is x to the 3, so this becomes the integral between 2 and 3. I'm going to move the pi outside, of x to the power 6 dx. If I integrate x to the 6, I get x to the 7 over 7, and that's evaluated between 2 and 3. So plugging those limits in, I'm going to take this over 7 out as well, so pi over 7 times 3 to the 7 minus 2 to the 7, which turns out to be 2059 pi over 7. Again, there's that working tidied up for you. So set up the integral between the limits with the function. integrate, work it through, and there's my final result. The next video in this sequence will look at a volume of revolution where we have rotation about the y-axis.